values to where the E is. And again, the E is right above the ln. So when you do this, just go to the E. The E automatically brings you up to the exponent. And then use your regular x and put a value in. That's all you had to do. Oh, they had to put 9.2 in here. Sorry. I didn't put 9.2. I'm going to put 9.2. And just hit it, and you'll get a nice answer. Again, round them to 3 decimal places, and that should be fine. Was everybody okay then doing this? Just plugging them in. Just a good exercise to get you used to base E. Remember, base E is a natural log because as x increases, as x reaches infinity, it reaches the same y value. So it's the closest to that y value, but it's very, very close to an exponent of 3 to the x. God bless you. Because it reaches 2.8 something or other. So it's very, very close to a base 3. It behaves just like that. Same domain, same range, same intercept. It even looks the same. Like when we graphed it yesterday, you could see one fell on top of the other. So it behaves nicely. But we just call it a natural base because that's the only one that actually approaches the same number. And this one again, what you need to be careful of, not so much in the 84s with the software on them. In the 83s, when you put this in and you raise like this is going to have to go in parentheses. You're going to have to put that in parentheses, otherwise it's going to raise to the 4 and then multiply the whole thing by 0.02. So make sure that you put this part in parentheses. So just a good example in doing that. We can graph these guys, same as we graph any other base because they are exponents. This one has a little other things going on in here. But we did an x squared in there too. Part of it looks like it's going to happen to get a little bit of a parabola, and then we kind of threw something else in there. So you can combine them. You can find your mids and your maxes. You can do your increasing, decreasing, your relative, your absolutes. Pretty much anything. Your x-intercepts, your y-intercepts. Your y-intercepts, we're going to set x equal to 0. However, your x-intercepts, we're not going to do those yet algebraically because your exponent contains your variable. The only way to get that down is with a log. So if you want to do it with your calculator and do a zeros, that's about as close, we'll get very close that way. But we won't get an exact x yet. When we hit the logs next week, at the end of next week, then we'll be doing these. Everybody can graph this? Now when you graph this, you may not see too close to that x-axis. Change your windows. Get used to changing your windows. Here's my E, and we're raising this to the negative x. Okay. When I graph this, I may not see what's happening. I know something's going on over there because I see a little blur. But if you want to, focus your screen right on this part. So if you go like this, just make y from like -2 to +2. -1 to +1. It's so close to the 1. So go to your window. Make your y min -2. Make your y max +2. And now it'll focus more on what's happening right there. Ah, you can see this. It didn't quite reach the 1. Maybe it's easier to do a maximum on now. You've got an absolute minimum. You've got a relative maximum. Okay. These were just really nice exercises with your graphs as well. These guys, interest problems. So, did I give you these? Is this what you had, right? Okay, so you had to invest $2,500 and change the parts for us. This is a standard interest equation. This one is when I'm compounding anything but continuously. This guy is continuous only. I can compound monthly, I can compound yearly, annually. I can compound daily, quarterly. So basically what they said was take a principal, find your rate, use your time, and see what amount you're going to get, and change your compound. Compounding annually, this was my annual, when n is equal to 1. You should see as you compound more, this was my quarterly, n is equal to 4. We get a little bit more money. Here's my daily down here, 365. Here's my semi-annually, n is 2. My monthly, and this is my continuously. Continuously uses PERT. PERT's going to yield you the highest. The difference between the daily and the PERT is not that great, because continuously is not like every single second. It has a certain algorithm that it follows, and I don't even know how often that it happens, but it's not as it's close enough to the daily. Let's put it that way. This is money, so round your money to 2 decimal places. If you don't put a $, I'm not overly concerned, but know that that's money that you're making interest. Again, yesterday we talked a little bit about this right here. This is an excuse me, this is an increase, and this is going to roll your money back in there by saying 1. Because if our rate is like 0.02, then what I'm saying is multiply it by 1, whatever your principal by 1, and add to it your principal times 0.02. So it's rolling in your money as we go. That's why it's 1 plus. When we do a 1 minus, it's going to be a depreciation or a decay. You guys do half-lives in chemistry? So that's a decay. That's a 1 minus something. That's your decay. Something's left over. Like maybe half of your element, or your whatever it is you're doing, half of your elements, right? Half of your element is left over each so many years. So that's the 1 minus. So if it's 1 minus a half, we're going to put a half when we do this. But we're going to get to that probably by Friday. And then the second one did the same thing. They just gave you a different time and a different rate. Now be careful on your rates. Again, 4% has to be flipped to a decimal. Once you put 1 in, just do second enter. Pull it down and change it. You can even, if you want to, I guess there's nowhere to store it. You could store n and just keep changing n, use it as an x and just keep changing the x, but it's probably easier just to pull it down. Is everybody good with this? Everybody can do this. Okay. Alright, and this one pretty much did the same thing, but we used PERT. We compounded continuously. So this time they can't change your compounding because we're compounding continuously, so they changed your time. 1 year, 20 years, 40 years, so you could see over time, up to 50 years, you're going to make the most out of 50 years. Again, the interest rates, we don't see those interest rates now. But if we put our interest rates in these problems, we would see very little change in your numbers. So in these problems, we still use some nice interest rates, 4%, 8%, 6%. You're going to see some good interest rates, because otherwise it's going to be so minimal, you wouldn't notice too much difference. So PERT has its own little formula for compounding continuously.